Alright, so on Friday we were getting used to using the graphing calculator, how we can type in an equation, how we can use the picture to help us answer particular questions. And I wanted you to try this one on your own just to see how far you could get with some type of the questions and what they were asking. So we have this lovely lady, Becky, who's in Vegas, and she's gambling, okay, just having a little bit of fun, not too much, right? And we have an equation that's modeling how much money she has during this one-day layover. So we're asked a few questions about this particular scenario. Any takers on number one? What does B of 12 mean? And find it. Go ahead, Sarah. All right, after 12 hours, how much money? All right, again, if you can't read my chicken scratch, let me know. Did you find it?
Yes.
What was it?
Negative 6.72.
And how did you find it?
I plugged in 12 and all the t's.
Perfect. She plugged in 12 for all those t's. Do we have anything for the office this morning? No? Okay. Thanks, Rachel. Good morning. I think we're good today. Thank you. Thank you. Yep. Have a good day. All right, so what's this telling us, this negative 672 in terms of scenario? Someone's struggling this morning. Oh, I just said your name too. Good, Maddie? She's in the hole. Yeah, okay. And can we kind of explain maybe why she's in the hole? Like, how can you have a negative amount of money? Can we make sense of what that's telling us? What do you think, Rebecca? She's in debt. Okay, so what's kind of happening here is, first of all, can we figure out how much money she started with? What was her initial amount of money? The moment she walked in? Yeah. 100. How'd you know that? Good, 180. Y intercept, close. Okay, so we're kind of getting a little ahead of ourselves. We're going to number 3 here. But if you were to plug in 0 for all those times, all those t's, at the very beginning she had $180. So she had 180, and then she kept gambling and gambling and gambling and losing, right? So eventually she would be back to 0 if she lost all the 180. But she went back to some type of ATM or the bank and had to get out more money. And apparently she lost that because she's down $6.72. So not only did she lose the 180 she started with, but she went back to get a little bit more and she lost that as well. Okay, so she's in the hole. She lost more than what she started with. That's kind of what's hinting there. Okay, were we able to get negative 6.72? Pretty good? All right, let's check out 2. What does B of t equal 80 mean? Any takers? Good, Maddie? The second half?
Like after the 80 equals 80 at the top,
that would equal, okay, so we have this equation we can use to help us answer the question. If you're plugging in 80 in for that B of t spot, what is that 80 representing? Oh, Hannah, go ahead, yeah. When she had $80. Okay, so we're going to try to figure that out. When did she have those $80? Now, this was a calculator question, so it might not be a bad idea for us to take a look at this together because we're getting used to this guy. Let's go ahead and type in our 2 equations. You can type in 80 and then the actual variable equation. All right. right, now before we hit graph, okay, you can hit graph, but I'm just saying before you hit graph, it might not be a bad idea to change your window to fit this scenario. Okay, make sure we have the picture we want to be able to look at. So let's go ahead and hit the window button. And we may have to change some of these numbers. The ones I have in here are from the last problem we did, I think the Pokemon tournament. So let's go ahead and change some of these numbers. We said T, that kind of X variable is representing the time that she's in Vegas for. And then the Y's we said was representing her total money. So what is the X min? What's the lowest amount of time she might be in Vegas for? Go ahead, Evan.
0.
0. Yep, could be. What about the longest she's in Vegas for? Go ahead, Hannah. 24 hours, perfect. So let's go from 0 to 24. And then the X scale, whatever you want to count by, you can choose this to be whatever you want. I'm going to count by 1s, 2s, 5s, 10s. 2s might not be bad. 12 tick marks. Okay, and then let's check out the Y's. So this is representing her money. What's the lowest amount of money you think she might have? Yeah, Marie? We can. Okay, we definitely know that she can go negative, right? Based off of number 1. So maybe we'll just say negative 10. Okay, that's a little bit lower than the negative 6. I mean, you can make that to be whatever you want. You can do negative 20, negative 15. Okay, you can always go back and change it if you want to. What's the most amount of money you think should have? Again, we don't know this, so this is a guess. We can always go back and change it. Right now it's in there as 100. Do we want to keep that? We think she's really lucky. You want to up it a bit? Go to Rebecca. She starts with 180. Okay, so we know at least that amount of money is what she has. Whether she gets more than that, we don't know. So maybe let's just say 200 to be safe. So we can definitely see that 180. Okay, we can always go back and change it. Now we're going from negative 10 to 200. So that's kind of a big range there. Whatever you want to count by, 10s, 20s, completely up to you. 15s, maybe I'll do 20s. Okay? So let's go ahead and hit graph. Alright, so we have this itty bitty piece right here. Notice how it's going up. And we can't see the top half of this graph, or that little hump there. So the 200 we picked might not be high enough. Let's go ahead back to window. And we got to pick something more than 200. You going to try 250? Again, it's a guess. We can go back and change it. And looks like we're going to have to. We were pretty close. It looks like she gets more than $250 at one point in time. Maybe we'll do 300. Perfect. Alright, so now that we have this good picture, where on that graph should we be focusing for this question? When does she have $80? Good, Marie? The intersection point, perfect, somewhere right there. So from Friday, do we remember how to find that point exactly? What buttons? Good, Ashlyn? We want to go to the Calc menu. Now the Calc is in blue, so you have to hit that blue button first. Which one are we going to select? Yeah. Intersection, yep, number 5. So go ahead and hit enter. That little spider or cursor pops up. Where can we go from there? Go, oh man. Maddie, go ahead. Sorry, Maddie. Go ahead.
Place the little cursor in the intersection.
So you might have to use your left and right arrows to move it. Okay, but you want to kind of get it close to where you think it is, that intersection point. And once it's there, good, Emily? 3 times. 1, 2, 3. Enter 3 times. Now notice how that word intersection pops up. Okay, you know that you use the correct buttons appropriately. So our intersection point, the time would be 11.179. So a little after the 11th hour, that's when she had $80. Now notice how that's the only intersection point on our calculator, so that's the only answer. Okay, the Pokemon one we did on Friday, there were 2 intersection points, right? So we had 2 answers. This one's not too bad. Were we able to get that yesterday? Not yesterday, Friday? Okay. All right, let's check out 3. What do the different intercepts mean? Y-intercept, maybe we'll check that one out. And X-intercept. Good, Rachel?
The Y-intercept would be her starting amount of money, and the X-intercept would be when she started gambling, the hour, I guess.
Close. Okay, X-intercept.
How to word it.
How to word it? Yeah, it can be a little tricky. Okay, so the Y-intercept is her starting amount of money. So graphically, okay, if you were to look at your picture, the Y-intercept is happening right there. Okay, and in terms of an ordered pair, that ordered pair we said was at the time of 0, okay, at the very beginning, and she started with $180. So when you're looking at a Y-intercept, the X value is always 0, okay, that beginning starting time, and your Y value is always a number. Okay, that's what's representing your initial starting amount. What do you think an X-intercept ordered pair might look like? Graphically speaking, that's that point. Hold on, let me, right there. If you were to try to find that ordered pair, what would it look like? Go ahead, Hannah.
A number and then spot no zero.
Right. Okay, it kind of switches. So for a Y-intercept, the X value is 0, but for an X-intercept, the Y value is 0. So in terms of this scenario, we know that the Y variables are representing money, and the X variable is representing a time. Now we don't really know what this number is. We could try to guess it, right? We can move our cursor, little spider dude, to that point to kind of see what it is. I think I counted by 2s, right? 2, 4, 6, 8, 10, 12. Kind of looks like the 12-ish spot, perhaps. Okay? But in terms of this scenario, this X-intercept is representing the time when she had no money. Do you see that? This would be a number, so this is the time that she had absolutely nothing in her wallet anymore. Okay? So we'll say the time when no money. Okay, I'm paraphrasing there. Not really a complete sentence, okay, but it's the time when she doesn't have any money. Does that make sense? Do you see how there's always going to be a 0 somewhere in an inner or an intercept? It just depends where it is. If it's an X-intercept or a Y-intercept. Okay? Now this one didn't ask you to find it, like find those actual values. They just wanted to know what they represent or what they mean. So I think we're good from there. We doing okay? Yeah. It's what? It's not? Okay. All right, let's check out our last one of 4. What is the most money that Becky had? Okay, so again, this might be a calculator question, or at least look at your picture maybe to determine what point we're looking for. Can we describe on this picture where we should be looking? Good, Rebecca?
Like the highest point very top.
There we go. We're trying to figure out that point right there, okay? AKA, it's referred to as a maximum. Okay, the highest point. So how might we be able to use the capabilities of our calculator to find that high point? Yeah.
You go in second and help.
Mm-hmm. Maximum. Okay, so when we were doing the Pokemon example, we were looking for a minimum, okay, the lowest amount. In this case, it's just the highest. Okay, so it's going to ask you the same questions as a minimum would. You have to move that cursor to the highest point. What's my issue, though? If I hit my arrow buttons, I can't get up there. How can I move my cursor? Yeah. Use an either up or down arrow. Yep, and it'll jump from one function to the next. So I think that's about my highest point. If it says left bound, I'm going to use the left arrow a few times to select enter. It then says right bound, so I'm going to go back to where I think that highest point is and hit the right arrow a few times. Okay, you should have those two arrows pop up. Okay, that's your way of telling the calculator you think the maximum is between those 2 points. Instead of making it check the whole graph, you only want it to check that little section. The last question's a guess, so you're going to go back to where you think it is and just hit enter. With that word maximum on the screen, that is the highest point that your calculator found. So we can go ahead and write that down. Alright, so now that we have those values, we need to kind of analyze what they mean to help us answer this question. What is the most amount of money that Becky had? Good. Oh, I want to say Brooke, but it's Brianna. Go, Brianna.
$268.25.
There we go. We'll round it. 25 cents. Do we know anything more about this maximum value? Yeah, Hannah.
She had this amount at 6.190.
At 9 hours. So not only do we know the most money she had, but we also know the exact time that happened. Now, that's not a part of the question, but it is another just useful piece to recognize. How do we do on that number 4, if we were able to get that far on Friday? Pretty good? Okay. We're going to get into a little bit more with the calculator today. Okay, if not today, definitely tomorrow. But we are officially done with our first section. Okay, so I did have a few questions kind of about the homework. Remember I told you guys I don't collect it until the end of the unit. Okay, but that doesn't mean you shouldn't be working on it. Not as much as you can, but just a little bit every day. Okay, so what we discussed on our first day, last Thursday, you probably should have been able to do the first page. And now that we've been getting familiar with the calculator, the other 2 pages might be more suitable now that you know how to use the calculator. Okay, so tonight, or if you haven't already, maybe go ahead and try some of these calculator-related questions. If you have any questions, you know you can always ask them in here. Okay? All right. All right, so let's go ahead and take a look at our next section on page 13. Another review section for us. We're going to take a look at linear functions. Okay, like you haven't seen enough of those already, right? Since middle school, perhaps. But we're going to amp it up a bit and talk about how we can analyze linear functions or even quadratic functions on our calculator. Okay, we're still getting used to this calculator idea. So at the top of your page, you have these 3 different forms of how a linear or a line function might be represented. I'm curious if we remember kind of the standard way that these 3 forms are represented. For instance, if I told you slope-intercept form, what's the first thing that pops in your head? It's probably been beaten into your brain for years. Yeah. Yeah. You had a wonderful Algebra 1 teacher, right? Yes. Okay, y equals mx plus b. Don't overanalyze these, okay? Mathematicians, they're not very creative. So if they call it slope-intercept form, you literally know the slope and you literally know the intercept, specifically the y-intercept. Do we remember which m and b value represent the slope or the y-intercept? The difference between the two? Good. Maddie, I'm sorry.
The slope is an m and the y is
There we go. All right, so slope is m, y-intercept is b. All right, so what we're going to do is let's pick 2 points here. We'll do 4, negative 10 and negative 12, 2. If we had those 2 points, how can we write the slope-intercept line equation that would go through those 2 points? Notice how if you know 2 points, somehow you have to figure out what the slope is or what the y-intercept is. Which one you want to try to tackle first? Go, Rebecca.
You could find the slope by using the equation y2 minus y1 over x2.
All right, y2 minus y1 over x2 minus x1. So that little slope formula is a way for you to take any 2 points and figure out the rise over run between those. Now the little subscripts, like the 2 and the 1, that just represents your first point or your second point. You just got to make sure that you're kind of organized in the way that you plug in these numbers. So what do you want to let y2 represent? You could either choose negative 10 or 2. Do we have a preference? Does it matter? No. Which one do you want to use? Do you want to use the 2 first? Yeah? Shaking your head? Okay, so we'll have 2, and then we need to subtract the other y-coordinate. So if we're subtracting a negative 10, we've got to be careful because that would change to a plus. Now the fact that we started with the 2 up top means we have to start with the negative 12 as the x value on the bottom. You have to be consistent. So this has to be the negative 12, and then we're going to subtract the 4. All right, so up top we have 12. On the bottom we have negative 16. Can we reduce that or simplify it? Good, Marie? Say it again. Negative 3/4. Thank you. Bless you. All right, so there's our slope, our rise over run. Now how can we use that perhaps to find the b value? How can we start to write our equation? Good, Maddie?
You take one of the points and plug it in for y and x, and then take the slope and plug it in.
Perfect. Okay, it doesn't matter which point. But remember, if you have a point, you have an x value and its related y value. So we could easily plug that information in for the x and the y. We just figured out what the m is. So that means the only variable left would be the b value, and we would be able to solve for it. So between the 2 points, do you have one that you would prefer to use? Again, it doesn't matter. You just got to pick one. Which one do you want to use? Good, Marie? The 4, negative 10? Okay. So negative 10 y value, negative 3/4 m value. The x value was 4, and we have a plus b. All right, so let's start to solve this for b. We have negative 3/4 times 4. This one's actually going to work out really nice. Do we know why? Can we see why? Go, Tori. The 4's cancel. One's being divided, one's being multiplied. Those cancel. So we're just left with the negative 3. And adding the 3 over, we would get negative 7. So there's our y-intercept. If we now put the m and the b together in the equation, y equals negative 3/4 x minus 7. So there's our slope-intercept equation of the line that goes through those 2 points that we started with exactly. We're doing okay? All right, so now that we have that equation, how might we use that equation to graph the linear function by hand? We know how to do that on the calculator, right? Y equals, type it in, not too bad. But how can we do it by hand? Can we graph a line? Good, Brianna?
Graph the y-intercept and then use the slope as rise over run.
Perfect. All right, so graph the y-intercept. We said that was -7. All right. And then use the slope as rise over run. So the slope is -3/4. From that point, we would have to go down 3 units and then right 4 units. But notice how we would be off our graph. How can we get around that little issue? Instead of going down and to the right, good, Grace? We could go backwards. We could go up and to the left. So let's go up 3 units and then left 4. Okay, so there's 2 points. That should be enough to draw a line. If you wanted to be a little bit more accurate, you could always repeat that rise over run again. Get another point. So there's our linear function. Now realistically, you perhaps could have plotted the 2 original points we had, right? But our issue is the graph was not big enough to fit those 2 points. So to get around that, using the equation might not be a bad idea. Okay? Slope-intercept form's probably been beaten into your brain for years. It seems like we're pretty good with that. What about standard form, though? This one's a little less common. Do we know what the typical equation would look like using some variables? What do you think, Tori? Yep, ax plus by equals c. Now what's nice about standard form is that a, b, and c are typically all whole numbers. Okay, you're not going to see any fractions. Notice how we had a fraction in the y-intercept form. So these are typically all whole numbers. For example, let's do 2x plus 3y equals 9. Now what you could do is turn standard form into y-intercept by getting the y variable all by itself. You could start to move things to the other side. But there is kind of a quicker, easier way to graph standard form type equations. Do we know that little shortcut, perhaps? We're going to use intercepts. Okay, remember we just talked about that. If we have an x-intercept and a y-intercept, what's special about those points? If we have an x-intercept, where's the 0 located? If we have a y-intercept, where's the 0 located? Good, Rebecca?
Well, if there's a probability that the y is axis is 0, that's the y-intercept. Then the y-intercept is the x is 0.
Perfect. Okay, it kind of switches. So what we're going to do is we're going to plug in 0 for x and y 2 different times, because plugging in 0 is really easy. 0 is nice to work with. If we were to plug in 0 for the y value, notice how this 3y would go away because we're plugging in 0, and we're just left with 2x equals 9. How could we solve that for the x-intercept? 2x equals 9. What would our x-intercept be? Go, Rebecca? 9 over 2, aka 4.5, however you want to represent it. Okay, so we just found that point on our graph. Let's go ahead and find the y-intercept. This time we'd have to plug in 0 for x. If we plug in 0 for x, that 2x would go away. So we're just left with 3y equal to 9. What's our y-intercept? Good, Emily? 3. So now that we have 2 points, specifically the 2 intercept points, we can plot those. And then connect those 2 intercepts with our linear graph. That one's kind of my favorite because plugging in zeros is easy. All right. What about point slope form? This one's kind of the beast of the 3. Do we know what the general form looks like with variables in it? Or what it kind of looks like, what's involved? I know you've seen it before. Y minus y1 equals m times, all right, x minus x1? We're shaking our heads yes, right? It looks familiar, it's a little involved, right? Okay, so let's go ahead and for this example, we're going to use the same 2 points as we did for the slope-intercept form. We're going to try to write the point-slope form equations. Now, if we're using the same 2 points, do we know what our slope should already be? Did we already find that? We said that was -3/4, right? And that's going to be useful because notice how we have to write in that slope in there anyway. Okay? So point-slope form, again, don't overthink it. Mathematicians aren't creative. You need to know a point and you need to know a slope in order to write this equation. So what's nice is we know 2 points. Again, it doesn't matter which one you use. So your equation might look different than your neighbor's, but it would still be the same line. Okay, it would still give you this graph. So let's go ahead and maybe write both of them. If we were to use the first point and that slope, what would our point-slope equation look like? The x1 and y1 are coming from your point, the x value and y value. Can we think about it? We need y minus the y value from the point. So if we're going to subtract the -10, that would change to a plus. We already know the slope is -3/4. And then we need x minus the x value from the point we chose. So we're going to be subtracting 4. So there's one point-slope form equation that you could possibly have. But maybe your neighbor chose the different point, the second point. What would that equation look like? Using the -12 and the 2. Good, Ashley. Ashlyn, sorry, go ahead.
Y minus 2 equals -3/4 times
X plus 12, perfect. 2 different equations, okay, but they would still give you the same line. If you were to solve these for slope-intercept, like get the y variable all by itself, you would get the slope-intercept equation we got from the very beginning. It's just a different way of representing it with the information that you know. Okay, so we have 3 different ways to represent linear functions. Is it coming back to us? Maybe we never lost it? Hopefully. Okay. Another characteristic about linear functions we can discuss is this parallel or perpendicular idea. Do we know the difference between the two? Can we describe the difference? What does parallel mean? What does perpendicular mean? Go ahead, Marie.
Parallel is along the line and perpendicular is
Intersecting. Okay, so parallel, you said along the line?
Like, they have the same slope.
Same slope. Okay, so we're definitely going to use that idea. If they have the same slope, that means their rise over run is the same. So if their rise over run is the same, they're never ever going to cross each other. Okay, there's no intersection points. So we have these parallel lines. Now, Marie said perpendicular means intersecting, which is true, but how they intersect is a little bit more important than just the fact that they intersect. Yeah?
They have an opposing slope, so it's the opposite.
Opposite, that's one piece of it. Go to Rebecca.
Oh, like it's like flipped opposite, like the opposite, like it's like if one is positive, the other one's negative, and both is like flipped.
What does that word flipped mean when you flip a fraction? Go ahead, Hannah.
They intersect at the right angle.
They do intersect at a right angle. So geometry-wise, you could put a little box in there, like a 90-degree box. Okay, that's wonderful. In terms of this flipping idea, go ahead, Evan. Reciprocal. Okay, so let's see. Parallel lines have the same slope, whereas perpendicular, they have what's referred to as opposite and, I'm going to put a little plus there, opposite and reciprocal. Reciprocal is that flip idea. Okay, so let's check out this example. Write the equation of the line that is perpendicular to this linear or line graph and contains the point 4, 5. All right, so if we're talking about perpendicular, we should be able to figure out a specific slope to use, and they also give us a point to use. So if we know a slope and we know a point, it might be in our best interest to use point-slope form. Notice how that's what you know, so that's what you're going to use. Can we figure out the slope we need to use if we want our new line to be perpendicular to this one? What do you think, Ashlyn? Positive 3 over 2. All right, so if you identify the slope in the equation they give you, negative 2/3, we need the opposite and reciprocal of that. So notice how this slope is negative. That means ours has to be positive. If this one is 2/3, then ours has to be 3/2. Okay, we flip it. So there's the slope of our new equation. We also need the point in our new equation, that 4, 5. Now what I've seen in the past is some kids, they kind of get tripped up on this +5, that kind of b value on the end. That's kind of insignificant to this particular problem, because the only thing you really need to analyze is that slope, because they gave you the word perpendicular. So don't get tripped up on that number 5. I know it's a part of the problem, but it's not significant. Okay, so now can we write the equation if we know a point and a slope? What would our point-slope form look like? Y minus the y value from your point equals your slope times x minus the x value from your point. Good, Marie? Uh-huh. X minus 4. Perfect. So there's our equation. Notice the directions. It just said write the equation. It never said write the slope-intercept form equation. It never said write the standard form equation. It never said write the point-slope form equation. You see how it's not specific? So if it just says write the equation, you can use any one of these you want. Okay? So in our case, it makes more sense to use the point-slope form. What if, okay, hypothetically speaking, the direction said write the slope-intercept form? Can someone describe what they would do for that? What do you think, Rebecca?
They would use the slope and plug in the 2 points for the y and x values.
Uh-huh.
The b value.
Find the b value. Okay, very similar step to what we did up here. Okay, so you got to pay kind of attention to the directions, but if it doesn't clearly cut and say what type to use, you can use whatever you're comfortable with. Okay, as long as you use it correctly. We doing okay? All right, so let's go ahead and take a look at how we can use these linear functions on a calculator. We're going to take a look at what's called regression. Have you guys ever heard that word before? Regression? Shaking your head, Marie. Do you remember what it means? It might sound familiar, but do you remember what it means? Say it again. Progression? Not sure. I'm interested in a mathematical sense. Like, what does regression mean mathematically? Okay. Have we heard the term line of best fit? That phrase? Maybe? Okay. So regression on your calculator is a way for you to type in data. Maybe you're doing an experiment. It's a way for you to type in data and to figure out, is there a correlation or a connection between the variables that you are comparing? Okay, is there some type of way to relate the two? So what we're going to do is we're going to type in this data table in our calculator, and we're going to let the calculator find the line or curve. Okay, sometimes it might be a curved best equation for us to find. So in order to type in this data, okay, let's make sure our calculator's on. we're going to hit the Stat button right next to your arrow keys. We're going to hit the Stat button because we're looking at statistics. We're looking at data points. Okay? Now you should have this little screen that pops up, and you notice how the cursor is highlighting the Edit button. See how it's on the number 1? I want you to hit Enter. And you should have this data table pop up. You might not have any numbers in yours, but do you have an L1 and an L2 at the top? If you don't, you gotta let me know because I might have to change your setting. No? Okay. Alright, if you have any numbers in L1 or L2, we're going to clear them out. That way we can type in the numbers we need. So in order to clear out these numbers, you're going to use the arrow buttons to go up to L2 or L1, hit the button Clear, and then arrow back down. You see how it deletes that entire column? So maybe we'll do the same for L1. Go to the very top, hit Clear, and then arrow back down. Okay, so L1 is kind of representing your X column. In this case, it's the total fat in grams of these different food items. And L2 is representing your Y column. In this case, your calories. So we're going to try to figure out, is there a connection, okay, is there a relationship between the fat in grams of a food object and the calories, the amount of calories it has. So what I want you to do is take the time and type in those numbers in L1 and L2. After each number, you're going to have to hit Enter so that it is stored into your calculator. You can use the arrow buttons to go from column to column. Can we have those numbers in there? Okay. What we're going to do is we're going to let the calculator graph these data points for us. It's going to create what's called a scatter plot. Maybe you've heard that term before. So what I want you to do is go to y equals, and if there are any equations in there, I want to clear them out because I don't want to look at lines necessarily just yet, or equations. I just want to look at data points. So let's go ahead and clear out anything that might be graphed that we don't need. Now, in order for your calculator to graph these data points, do you see how right above the y equals it says stat plot? We're going to plot the statistical data we just typed in, and it's blue, right? So we have to hit that blue button first, and then the y equals. What we're going to do is we're going to turn the plot one on. That way it graphs the data points. So go ahead and hit Enter. And we're now going to hit Enter again to turn it on. You see how that cursor kind of changed, went from off to on? Okay. Now before we hit graph, just like with any other graph we want to show up on our calculator, we might have to change the window. So let's go there. The window we have in there now is from the other problem, okay, our Vegas example. We might need a different window for this one. So take a look at your data table. Okay, the numbers are kind of jumbled, they're not necessarily in order, but we got to figure out what's the lowest X value. AKA, what's the lowest fat gram in our column? Good, Maddie? It's 5. Okay, now just to be sure that we can see that data point of 5, I want to go a little bit less than that. Maybe 0, maybe 3, it doesn't matter. Maybe we'll do 0. Just to make sure we can see that number 5. Okay, what about the largest fat gram? Good, Maddie? 34. Now, in order to make sure we can see that data point, let's go a little bit higher than that. Maybe 35 or even 40. Completely up to you. If we're going from 0 to 40 in this case, what do you want to count by? 1s, 2s, 5s, 10s, completely up to you. Yeah? 5s? Sure. Okay, let's do the same thing for the Y's. What's the lowest amount of calories? Good, Ashlyn?
260.
260. Let's go a little bit less than that, just to make sure we can see it. So maybe we'll do 240. And then the highest calorie looks like about 590. So let's go a little bit more than that. To make sure we can see it, we'll try 600. 240 to 600, what do you want to count by? 20s, 40s, completely up to you. Okay, maybe we'll do 40s. All right, so with our stat plot on and our window appropriately measured, let's go ahead and hit graph. Those are all the data points from your table that you plotted in. Okay, now if you were to draw an equation that would be as close to those data points as possible, would it look like a straight line? Would it need to be slightly curved? What do you think? Good, Maddie? It looks like it would be a straight line. Okay, so since the data is resembling a straight line, we're going to use what's called linear regression. We're going to find the line equation, the line of best fit. Okay, so this is where we're going to take a look at our first question at the bottom there. Okay, we're going to find the equation. So now that we know what the data looks like, let's go back to the stat button. Okay, that's where we typed in the data, remember from before? But instead of hitting enter to type in the data, we're going to scroll over to the calculate menu, use the arrow button. And if you kind of scroll through your options, do you see how number 4 says linreg? That stands for linear regression. If you take a look at number 5, quadreg is quadratic regression. Maybe your scatter plot looked like a U. Okay, if it looked like a U, we could use that. There's cubic regression, quartic regression, exponential regression. We're going to take a look at a bunch of these this year. Okay, but for now we're just going to use linear regression, which was number 4. Okay, so make sure that the number 4 is highlighted and hit enter. You might have this this screen that pops up. Okay, it's okay if it does. Just keep hitting enter until you go down to calculate and hit enter again. Do we have the same numbers that pop up? Yeah? This happened? What happened? It's a different operating system, but it works the same way. Okay, so can we get those same numbers? Okay, so what the calculator is telling you is we're used to y equals mx plus b, but your calculator has an a there instead of an m. Okay, but that a still means the slope. So what we're going to do is we're going to write our equation. We have y equals 11.73x plus 193.85. Okay, we're going to use that tomorrow to answer the 2 questions at the bottom, okay? And we're going to do another example of this regression just so we can get used to our calculator.